Okay, so in this question here, this is week week is it week 10 in WebAssign, chapter 8 in the Think Do book. And what I'm seeing is, so it's always good to do a conditioning check to make sure you're going to run the right tests. So I see weights of salmon, so I know this is not a categorical variable, but it's a quantitative variable. That tells me I'm either going to use a Z test, a one sample Z test, or one sample T test. Now, they're telling me that the weights for these Chinook salmon are normally distributed. But what I'm not seeing is I'm not seeing the population standard deviation. That tells me I'm stuck using a t-test. And they kind of, do they tell me that here? I see they kind of hint to that they tell me what's the test statistic for this. So I could certainly find the mean. So let's compare this to this question in the textbook. So in the textbook here, they tell me the mean, they tell me the standard deviation, and I get a sample of 25 or 20. And so I could do all that, all by hand with the table. I could also do it with applets. The applet that I have right here that I like, this is my go-to significance testing applet. It doesn't do Z-tests, but it does do t-tests, one proportion Z-test, one mean t-test, and it also does two sample t-tests. We'll see that in chapter 9. So this is my goal. I really like this applet because it gives me a picture. I can do confidence intervals. I can do significance tests. You probably saw this last week if you watched some of my videos. So what I'm going to do, because I know it's going to mean, one thing I ought to do before I go much further, I always got to do this. So I did the condition check. So what I want to do is come back here, and I got to decide on HA. That's always an important thing to do before you do anything else. So they're telling me I'm trying to see if the mean, what's the claim? The claim that the mean weight is greater than 25 pounds. So I would say, in this case, I would say HO is equal to, the mean is equal to 25 pounds. And then we'll try with H1 or HA being the claim where it's greater than 25. So I'm going to call this the claim. Sometimes what happens when you're doing these tests, you get a p-value that's bigger than 0.5. And if you're doing a two-tailed test, yes, it's possible to get a p-value bigger than 0.5, bigger than 0.5. But typically that means you went the wrong direction with your H1. So, and sometimes you're going to change your thinking. I tend to try to make H1 be my claim, but sometimes it's not. If you look at some of those cookbook kind of exercises, some of those are the claim will be HO. But it's all how you set it up and how you think about it. So I've got those. That'll help me do this work. So now I've got to get this data here. So I could certainly calculate the mean, the standard deviation. There's software that does that. Can you do it by hand, do it with a calculator? I hope you don't do it by hand. So, but what I'm going to do is, the great thing about this Rossman Chance applet is I can just select the data. And notice I went from the bottom up. Sometimes top down works. There's all these hidden characters in this code, and you got to copy it in such a way that the software can understand it. So I'm trying it right now, going from the bottom up. And I'm copying that. I'm doing a Control C on my PC. You do a Command C on a Mac, and a Chromebook. You do Control C. Then I'm going to select. Well, make sure you select one mean. Make sure you select paste data, and I'm going to clear out the data that's in there. And then I'm going to Control V the data in, and that looks like it's pretty good. So I'm going to click Use Data. I'm seeing that some issues here. One thing in the condition check that I didn't do is this sample is only 15, a size 15, which for the central limit theorem to hold, it's got to be 30 or more. But if we come back and take a look what they told us that the weight of the Chinook salmon in the Columbia River are normally distributed. So the condition is sample size bigger than 30 or normal parent population. Well, we get a normal parent population, so we know the sampling distribution of these weights the average of these weights is going to be approximately normal. So I've got this data in. I'm going to come back to my Rossman Chance applet. See, I've got my HO and H1 here because that's going to help us do a test of significance. and I'm saying 25 is equal to, and then I'm going to change this so it's greater than. I'm going to calculate it, and I'm getting, see, here's my nice graph. Here's my test statistic. So that's what I'll type in to this. Where's the web assignment here? So what did I say? 1.75. Hopefully that's enough decimal places. 1.75. My p-value is that p-value that got reported out. So 0.0514. Now at the 10% level, now we're going to make a decision. So at the 10% level, my p-value is less than 10%. So it made it under the limbo bar. We're going to reject HO. It looks like the data supports the claim. So the data supports the claim that the mean weight, let's see, what are the other options? We're not going to, there's enough. I don't like this, the way he words this, enough data. We've got enough data. I don't think the data supports it is the way to claim it. I really like that flow chart. If you look at my, testing helps notes, I like the way the flow chart words it better. But Dr. Stevens was fine also. That's just Dan LeMay's opinion getting in the way, and my opinion is not always that accurate. So let's see. The data supports claim. I still think, we certainly haven't proven. We never know this for sure, because we could be making a type 1 error, right? We're saying we're going to reject HO, but what if we're wrong? That's a type 1 error. So we could be doing that. We can just say the data supports that. Let's see. I guess I can't click just the one, huh? But that's how, and this is a right tail test, yeah. So that's how I would answer this question. I hope that helps. Pretty easy to copy and paste that in.